using the derivative, or finding the derivative using the definition of derivative. And notice here the directions. I want to point out here, make sure you guys understand that they're not always going to say just find the derivative of this, find the derivative of that. Here they're saying find dy dx, okay? And find the rate of change at x equals 4.
What's our function?
Okay? The function in this case is x squared. Okay? So they might also say find the slope of the tangent line through the point 416. Okay? This is telling you to do the same thing as the original directions. You're finding the derivative, then you're plugging in 4 for x to figure out what the slope is at that point. Okay? So let's work our way through this. We have x squared. So what we need to do now, without our phones, is this. We take x plus delta x and we plug it in for x, and square it, and we FOIL it out. Okay? We FOIL it out. X squared plus 2x delta x. By the way, x times delta x is just x times delta x. You can't make it like delta x squared. Okay? It doesn't work that way.
I probably would have written that.
So, but delta x times delta x you will write as delta x squared. Okay? So now we're going to use the definition of our limit.
And now we can just plug it all in?
Now we just plug it all in, okay?
That's
So here's the f of x plus delta x. X squared plus 2x delta x plus delta x squared minus f of x. F of x is x squared. And look, just like we wanted it to, the only two things that don't have delta x's in our numerator are the x squared and the minus x squared, and those cancel out to 0. Okay?
Wait, Mr. Dixon,
Yes.
can you go up there for a second? So it's f equals, it's f, in the red,
Yes.
f of x plus delta x
Mm-hmm.
always equals x plus delta x squared?
Well, for this function it does, because this function is x squared. You're plugging this in for x.
Okay, so then when you put it, okay.
Okay? Just like back here, we plugged it in for x, 4 times the x plus delta x minus 5.
Okay, so
Okay.
you always plug x plus delta x into your f of x.
Yes.
Okay.
Okay? Now, notice here what's left. We have 2x delta x plus delta x squared over delta x. All the terms have delta x's, so I can cancel that out, and one of those out.
Why?
Well, because there's only one down here, so you can only cancel out one of them.
But you already canceled.
Yeah, you already used it.
Well, no,
That's
you're
not
canceling
how
out a
fractions
common
work.
factor,
Gotcha.
right?
No.
It's a common factor of delta x, so you got to cancel it out of both of them.
Okay, I understand.
It's like we factored delta x times
It's like if you had
2x
two fractions.
plus delta x,
Think of
right?
it like separate fractions.
A polynomial.
Well, hang on, just watch.
Okay.
We have a common factor here
Yeah.
of delta x. If you factored it out,
Yeah.
you would cancel that out with that.
Yeah, and then why did you cancel one of the other ones? Oh, you did. Okay. Now you're left with x, with 2x plus delta x.
Yeah, now we're left with 2x plus delta x. And notice here, the whole point of why that's significant is that now we can take the limit by evaluating. We can simply plug in delta x equals 0. Up here we would have gotten an undefined value. Down here, we can just plug 0 in and we get 2x.
So that means that it is dependent on the time because
Exactly. F prime of x is going to be 2x.
So 2 whatever.
Yeah.
And then the delta x is, it's just like another, like it's basically like y. Like the delta x is, because it's the change in x, so it's like they're stuck together.
Yeah, and actually there are some formulas that'll use h instead of a delta x, just to avoid confusion.
But
So,
you can plug whatever it's approaching into delta x.
yes. Yeah, now that you don't have it in the denominator, you can. Okay? So now let's take the next step here. What's the slope of the tangent line through the point 416? Okay? We've got the function x squared. Here's our function x squared, and here's the point 416. Well, there's this tangent line going through that point. Okay? Ooh, I hit it. All right?
I'm gonna go.
Okay. Have fun.
Where are you going?
I'm gonna go sing in a nursing home.
You what?
That sounds good.
Okay. So what we're trying to do here is we're trying to find the slope of this line. Okay? And that slope is going to be f prime of 4.
What do you do with the y?
You
The
don't.
y doesn't matter because notice our derivative is only dependent on x. Okay? So f prime of 4 is 2 times 4. So that's 8. So the slope of this line is 8.
Why? Why would that give you the slope?
Because that's what a derivative is. Remember yesterday when
no,
we...
I know, but you just pulled 416 out of nowhere.
It's a point on the line, on the graph of x squared.
Like I understand everything we did up, okay?
We could find the slope of the tangent line at any point. Like, let's say we wanted it at -1. The point -1, 1. There's a tangent line here. Okay. If I wanted the slope of that tangent line, I'm going to take f prime of -1. So, 2 times -1.
Oh, it's the slope of the tangent line.
Yes.
So that's why
Which is
it
the slope.
depends on the point. Okay,
Yes.
okay.
Yeah, it really is giving us the slope of two things. It's the slope of the tangent line. It's also the slope of this curve at that exact moment. But it's so hard for us to like think of just a moment that's why we draw the whole tangent line. Think of it this way too, like let's say something was swinging along here, along this path. If you let go of it at this moment, like if it were swinging along here, coming down from the left, and you let go, it would fly off at a tangent, okay? Just kind of like if you're, you got one of the old school slingshots, and you're swinging it around and around and around and around and around and around. Wherever you let go, let's say you let go here, it's going to fly off at a path that's tangent to your circle.
And it's the slope.
At that moment, yeah. And if you wanted to know exactly where that is, you've got it.
So derivative is the slope.
Yep. And by the way, that's
So
how...
what's an integral?
Area
The-
of the curve.
Yeah, we'll get to that later. That's how, guys, here you are orbiting the moon, and you need to get back to Earth,
Draw the eye.
and you need to hit here, okay? If you need to hit the Earth here, they need to time you getting out of the moon's orbit just right so you don't end up shooting off here. Okay? So they have to figure out exactly when to shoot off so you'll aim the direction you're supposed to aim. Okay?
No, that's not what I meant. I meant the other eye, because then that'd be an eye. But it's a,
All right.
you got it.
So here's the deal. We can do this with any of these functions and they all behave the same. For this one, we would simply take the x plus delta x, square it plus 3 times x plus delta x minus 5 And we would simplify that. X squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x minus 5. This whole thing is f of x plus delta x. So we would take that thing and we'd plug it into our formula, and I'll cheat a little bit here. Okay? There we go. That minus x squared plus 3x minus 5 all over delta x. Notice here, when I simplify, x squared minus x squared is 0. 3x minus 3x is 0. Negative 5 minus a negative 5 is 0. All I've got left are delta things with delta x's, so this will cancel out that, one of those, and that, leaving us with 2x plus delta x plus 3 that we're taking the limit of. So we can now plug that in and get 2x plus 3. Okay? Delta x will always approach 0 when we're finding the limit. There's an alternate definition that has x approach h, and then it's over like x minus h. It's used in certain cases where it makes the algebra a little easier, but we're just going to use this one. Okay. All right, you're welcome. Yeah.